survive. We'll see. All right. So in this section, we're going to go over sum and difference identities. This section is going to be a lot easier for you if you have this calculator. It's not impossible if you just start working with your graphing calculator. I'm just letting you know that it's going to be easier if you have this calculator. So with that said, this calculator is like $20. You know, if you want to go purchase it, I would say that this section as well as later sections will probably be made easier if you have this calculator. Or maybe you know someone that has it and you can just borrow it for the test. All right, so let's look at, first let's take a look at our sum and difference identities and just talk about how they're different. All right, so here's the sum and difference identities. The first sum and difference identity is for sine of u plus v. U and v here represent angles, so maybe this is like, you know, 15 degrees plus 75 degrees. So then you would replace u with whatever that angle is. I think we said 15 degrees, so everywhere there's a u, you would put in 15 degrees. If v was 75 degrees, you would put in, everywhere there's a v, you put in 75. All right, so this one is for sine of u minus v. Let's compare these two here. This one says sine cosine plus cosine sine. This one says sine cosine minus cosine sine. And then we have cosine of u plus v and then cosine of u minus v. These are very similar, just the sign in the middle is different. Same as that one up at the top. And then here, for tangent of u plus v, the difference is again in the sign. So up top here you have a plus, in the top here you have a minus, in the bottom you have a minus, in the bottom here you have a plus. So just be careful with the signs on these because it's super easy to get a sign messed up and then you're, you know, using the wrong formula. All right, so let's talk about this first problem. Let's talk about how you would do it if you have this calculator and how you would do it if you're working with a graphing calculator. It says use sum and difference identities to find the exact value. Exact value means no decimals. So exact value means no decimals. Like if there's a square root in there, you got to leave the square root. If there's something like pi in the answer, you want to leave pi in the answer. So exact value means don't round, don't approximate. So your homework is going to tell you to look at this expression, match it up with the sum and difference identity from your sheet. So this is sine of an angle minus an angle. So then you would go over here and say, okay, well, there's the identity for sine of an angle minus an angle. So I would use this identity here. And that's how you'll do it if you have a graphing calculator. But if you have a this TI-36X Pro, you can just type this in. And it will give you the simplified answer. What mode should we be in if you're typing this in your calculator? Radian. Good, radian mode. Now, if you have this calculator, you can go ahead, plug it in, and if you don't, then just keep listening because I'm going to show you how to do this without using the calculator. All right, so the reason you can't do this on a graphing calculator is because it's going to give you a decimal answer, and this wants exact values. So you could plug this in, you know, it's just, it wouldn't give you an exact value. All right, so we're going to use that sum and difference identity that I just showed you. I'm going to copy it down right here. So it says sine of u minus v equals, let's see, sine of u cosine of v. I don't know why they use u and v, which are like the two most similar looking letters in the alphabet, but they didn't ask me, so. And then that's cosine of u, sine of v. U and v again represent the angles. So here, 7 pi over 4, that's u, 5 pi over 6 is v. All right, so we're just plugging these into our formula. All right, so that's equal to sine of u, so that's going to be sine of 7 pi over 4, times cosine of v. V is 5 pi over 6. And then minus in the middle, minus cosine of u, so cosine of 7 pi over 4 times sine of b. Again, b was 5 pi over 6. All right. Now you're going to grab your unit circle and then just, replace each of these with their exact value. So 7 pi over 4, let's see, that's in the fourth quadrant. And then we're doing sine of 7 pi over 4, so that'd be the y value. So that would be negative square root of 2 over 2. All right, so that's negative square root of 2 over 2. I'm going to put it in parentheses because I'm going to have to multiply it by something. All right, cosine of 5 pi over 6, that's in the second quadrant. Cosine's the x value, so that's negative square root of 3 over 2. All right, so negative square root of 3 over 2 minus cosine of 7 pi over 4, so back to the fourth quadrant, x values, because we're doing cosine, is square root of 2 over 2. And then sine of 5 pi over 6, back to the second quadrant, y value is 1/2. Okay, so almost done here, just got to multiply these, and then write them as one big fraction. So just some basic algebra reminders here. When you're multiplying two radicals that are like the same type of radical, like square roots or cube roots, you can multiply their radicands. So negative times a negative is going to be a positive, and then multiply the radicands. So 2 times 3 is 6. So that's going to be square root of 6. Again, it's positive because it's a negative times a negative. And then here we've multiplied numerators. Now we'll multiply denominators. 2 times 2 is 4. Minus square root of 2 times 1 is square root of 2. Multiply denominators. 2 times 2 is 4. Now, luckily for us, and this will happen on every problem, almost every problem, I would say. There could be some instances where you end up here having something like just 2 or just 1, just a whole number instead of a fraction. But most of the time, you're going to be left with common denominators here. So super nice. You can just go ahead and subtract the top. Denominator stays the same. So that's going to be square root of 6 minus square root of 2. All over 4, and this is your final answer. Now, if you plug this in your calculator, it's going to look a little bit different, but it's equivalent to this answer. So on your homework or on your calculator, they go ahead and combine this into one big radical, which is not necessary on the homework. They will accept this as the answer. It's just not like truly simplified. All right, so again, this is equivalent to what you're going to get out on the calculator. So let me show you what that looks like. Make sure I'm in radian mode. All right, so sine of 7 pi over 4 minus 5 pi over 6. Oh, and it did show up the same on this one. Sometimes they show up a little bit differently. So that one was good. So with that said, this is the amount of work it will save you if you have this calculator. I'm sounding like I'm not going to get a commission off of this. I'm not, but it does make your life easier. Maybe I should try to get a code for Texas Instruments so I can make some money. All right. This is a little bit more difficult. Whenever they just give you a single number, you have to think in your head, like, okay, how can I split this up into something plus something or something minus something. Now, again, if you have the TI-36, you just plug this in, sine of 255. But if you are doing this by hand, you're going to have to think, okay, what are two numbers that would add to 255? Always, if I end with a 5 here, if my number ends with a 5, I'll try to do like 45 plus something, just because I know that, that's going to give me a 5 at the end. So let's see what 255 minus 45 is. That's 210. That's another number that's only useful. So we could do 210 plus 45. There's more than one way to do that. So we say 210 degrees plus 45 degrees. Let's see, you might could do, I'm trying to come up with like two different numbers, but let's see, 255 minus 135. You could do 135 and 120, add those together. It doesn't matter how you split them up. You're going to get the same answer either way. All right, so now that you have this split up into sign of a number plus a number, you can go to your sum and difference identities, sign of a number plus a number. That's the first one there. So it's going to be sine of u cosine of v plus cosine of u sine of v. So I'm going to write that down here. All right. Now you're just going to plug in u and v. So 210 is u in my problem. V is 45. All right, so I would do sine of u, that's sine of 210 degrees. Cosine of v is cosine of 45 degrees. Plus, or sorry, not plus, minus. Did I do something wrong? Ooh, that was a close one. That's supposed to be a plus. Close one. Okay. When I was looking at this, how I knew that I had done something wrong is because the way I had written it down was the exact same way that I'd written down the last one, which could not be correct because the last one was minus, this one is plus. So I saw that these could not be the same, so that's how I knew I made a mistake. All right, so let's finish this. Cosine of u, that's cosine of 210 degrees times sine of v, so that's sine of 45. But now you just, again, go to your unit circle, figure out what sine of 210. 210's over there in the third quadrant. Sine is the y value, so that's negative 1/2. Negative 1/2. Cosine of 45, that's in the first quadrant. Cosine is the x value, so that's square root of 2 over 2. Plus cosine of 210. Cosine is square root of 3 over 2. Negative, of course. And then sine of 45 is also square root of 2 over 2. So I looked at my angle and I know cosine's the x value. So that's, yeah. So that's always probably something that you'll want to add to your little formula sheet. Is this stuff here, like cosine is x value, sine is y value. This is something that we keep using over and over, so you may have it memorized by the time we get to the test, but if not, definitely consider adding it to your formula. All right, so now we just have to multiply these and write them as one big fraction. So let's see, that's going to be negative square root of 2 over 4, and then plus negative square root of 3 times square root of 2 is negative square root of 6 over 4. Y'all tell me if I mess something up because I have been numb. All right, plus a negative, that's going to be a minus. Denominator is the same, so you don't have to worry about finding a common denominator. And there you go. So let's check on our calculator to see what it shows up as. Put in degree mode. Sine of 255. 6 and the 2 were switched. Same answer. Okay. I don't have a set of these, so I can't bring in a set of these for the test. I only have a set of the graphing calculators. All right. Now, this next one is probably what I would consider to be like the hardest of the problems on number 1. Cosine of negative 7 pi over 2. So what your book would probably show you to do, or what your homework would probably show you to do, is they would probably try to split this up into like a sum or a difference of two fractions. But my suggestion to you is that if you're trying to do this by hand without using, this calculator, then I would go ahead and switch this to degrees, because it's going to be much easier to try to think of two numbers to add to that in your head if it's a degree measure. So let's go up here and convert negative 7 pi over 12 to degrees. So we're going to multiply by 180 over pi. Pi's cancel. Again, if you're plugging this into your calculator, you would just plug this straight in. You don't need to convert anything. Just make sure you're in radian mode. All right, so let's see. Negative 7 over 12 times 180 is negative 105. So now that's in degrees, so you can put your little degree symbol on there. So that's the same thing as cosine of negative 105 degrees. Now, negative 105 is not on the unit circle, neither is positive 105 degrees. So you want to think of two numbers that would, preferably in this case, subtract, because it's negative. So subtract to give you negative 105. Let me see. I think I was just kind of picking some numbers here and trying to see, okay, what would I have to do 180 minus 105? Okay, 75, that's not on the unit circle, so that's not going to work. And then maybe I tried like 135. Let's see, 135 minus 105. Both of those are on the unit circle, 135 and 30, so we could use those. All right, so now we got to figure out how to make it negative. So let's see, if we do 30 minus 135, that gives you the right combination. So you can just kind of play around with these numbers until you find the right combination that are going to add or subtract to give you that value that you're looking for. So we'll do cosine of 30 degrees minus 135 degrees. All right, so that's cosine of 30 degrees minus 135 degrees. All right, so then you go over to your list of trig identities. You look at your sum and difference. We want cosine of an angle minus an angle. So again, they're using u and b, so that would be cosine of u minus b. All right, so cosine of u minus b is right here. It's the fourth one down. And I know it's hard to read, but it says it's cosine of u, cosine of v, plus sine of u, sine of v. All right, so just going to write that up here. Okay. And let's see, here U is 30 degrees, V is 135. Okay. So then you would do cosine of U, cosine of V, so that would be cosine of 30 degrees, cosine of 135 degrees, plus sine of 30 degrees, sine of 135 degrees. Let me see if I can get all this in here. All right, now go to your unit circle, figure out what is cosine of 30 degrees, what is cosine of 135, cosine's x value. So cosine of 30 would be square root of 3 over 2. Cosine of 135 would be negative square root of 2 over 2. All right, so plug those in. Square root of 3 over 2, negative square root of 2 over 2, plus, let's see, sine of 30, so sine is y value, so that'd be 1/2. And then sine of 135 degrees is positive square root of 2 over 2. All right, so 1/2 and positive square root of 2 over 2. Same deal, multiply these out, combine them into one big fraction. So square root of 3 times square root of 2, that's going to be square root of 6, and it's a positive times a negative, so it's going to be negative 2 times 2 is 4, plus square root of 2 over 4. Combine them into one big fraction because they have the same denominator. So negative square root of 6 plus square root of 2 all over 4. Okay.
Why did we switch to adding?
Adding was part of the formula.
Oh, okay.
Yeah, so since it was adding in the formula, we kept it throughout. But you should be careful because sometimes you'll have something up here, maybe a negative that might change this to a minus. So just be careful with your signs throughout the problem. Now the last two on number 1, part D and part E, are a little bit different. They are already written out for you. So you can see it's written out sine of 55 degrees, cosine of 35 degrees, plus cosine of 55 degrees, sine of 35 degrees. So you're going to look at this and say, okay, this is sine cosine plus cosine sine. All right, then go over to your sheet. We're looking for sine cosine plus cosine sine. So we're looking over here on the right-hand side of our formulas. We want sine cosine plus cosine sine. That would be this first one, right? All right, so that tells us that we've got the right-hand side of this formula. So let's go ahead and convert it over to the left-hand side. So that's going to be sine of u plus v. So sine of u plus v. And we know that 55 degrees is u, 35 degrees is v. All right, so 55 is u, 35 is v. So that's going to be sine of 55 degrees plus 35 degrees. What's 55 plus 35? 90. All right, so sine of 90 degrees. What is the y value at 90 degrees? 1. So that's our answer. Again, you could just plug this in if you have this calculator. I guess technically, since it's going to give you a really simple answer like 1 here, you could also do this on the graphing calculator. So this one will be fine for either one. If these where it's going to give you this weird answer with radicals, that's the ones you can't do those on the graphing calculator, which of course you don't know that when you first do the, start the problem. You don't know if you're going to have a weird answer or, something normal for your answer. So maybe it's best if you have the graphing calculator just to start them all by hand. All right, last one looks the worst. It's not terribly difficult though. So part E looks just absolutely awful. Big fraction, lots of tangents, and weird angles. So this one says tangent of 23 pi over 24 minus tangent of 17 pi over 24, all divided by 1 plus tangent of 23 pi over 24 times tangent of 17 pi over 24. So we've got tangent minus tangent in the numerator. So look for the one with tangent minus tangent in the numerator. Bottom one, good. So tangent of u minus v. So this is going to be tangent of u minus v. And again, here we're just looking for the exact value of this expression. Either way, if you have this calculator or not, I think this is probably going to be the easiest way to do this. So let's replace u and v with what they are defined to be. U is the first angle here, v is the second angle. So let's plug these in. So this is tangent of 23 pi over 24 minus 17 pi over 24. These, again, super nice for you guys. This has a common denominator, so you just subtract the top, bottom stays the same. So let's see, 23 pi minus 17 pi. You can just treat pi like it's an x, like it's a like term. Just subtract the coefficients. 23 minus 17 is 6. All right, so that's tangent of 6 pi over 24. So again, you kind of treat that like it was 23x minus 17x. That would be 6x. So don't lose the pi, basically, is what I'm trying to say. This reduces to pi over 4. All right, tangent pi over 4. Remember, tangent is y over x, y coordinate over the x coordinate. So grab your unit circle. Pi over 4, y value is square root of 2 over 2, x value is square root of 2 over 2. So what is y over x going to be? 1. Good. The more you do those, the faster you can get at figuring out which ones are going to be 1 or whatever. So those both cancel out. So this is just 1. So like I said, I think that even if you did have the TI-36, this is probably the best approach. Because it would be so easy to accidentally mess up when you were typing this in on the calculator. So this is probably my suggestion for how to approach this either way. All right, so that was the end of number 1. Number 1, again, was finding exact values. This is definitely the harder of the 2 examples that I have on the notes today. The last example, number 2, and again, it's parts A through D. We're just going to read the directions here, and I'm going to explain to you what it means. It says, use the sum and difference identities to rewrite the expression as a trigonometric function of a single number. That means just condense this down, write it as sine of whatever, or cosine of whatever. Don't evaluate it. So don't plug it into your calculator. Just use the trig identities to condense this down to a single expression. All right, so this one's going to be much easier because we don't have to worry about doing anything with the calculator or the unit circle. All right, so sine of 15 degrees times cosine of 135 degrees plus cosine of 15 degrees sine of 135 degrees. So it's sine cosine plus cosine sine. All right, so grab your sheet, find the one that's sine cosine plus cosine sine. First one, good. So that's this one, sine of u plus v. Okay, so u is 15 degrees, v is 135 degrees. So that's going to be sine of 15 degrees. And I'm adding in like all the steps. You could probably do some of this in your head and you could skip a lot of this writing. What's 15 plus 135? 150. And then stop. This is it. This is the answer. Now, if I was to put one of these on the test, this is what I would want you to look out for. And this is something that happens on every test, every trig test. Don't forget to put in the degree symbol. All right, so let's add a little note here. Don't forget the degree symbol, because I have to take off points if you don't put the degree symbol, because if there's no degrees, then that's radians. So don't forget the degree symbol. That could be something that maybe you want to add to your little green sheet. Like at the top, just write big bold letters, don't forget the degree symbol. And yeah, that's pretty much, that's the only thing I envision having to take off points for. Otherwise, I think everyone will do well on these. Let's look at this one. Cosine minus sine. So look on your sheet, which one is cosine minus sine? Third one, good. Cosine of u plus v. Go ahead and label which one's u, which one's v. They're going to always go in alphabetical order for sum and difference identities. First angle is always going to be u, second angle is always going to be v. So just plug those in and then simplify 2 pi over 5 plus 3 pi over 5. Again, you're going to treat this pi like it's just an x. So don't, get rid of the pi. Just add the coefficients. That's going to be cosine of 3 plus 2 is 5. So 5 pi over 5 is what? Yeah, just pi. That's it. Don't go any further. That's the answer. So you're going to pay close attention on this one on the test, like, and of course on the homework as well, but which one should I, actually go to my unit circle and evaluate it? Which one do I stop when I get this single expression? All right, just two more. They're both the tangent ones. Which one has tangent minus tangent in the numerator? Which of the trig identities? Good, last one. Tangent minus tangent in the top is right here. So that's tangent of u minus v. So label u, label v. So that's going to be tangent of 60 minus 35. Put my degree symbols in there. It's okay if you leave the degree symbols off here. It's just in the final answer that I need the degree symbol. All right, 60 minus 35 is 25. So that's tangent of 25 degrees. Stop there. So stop when you get, a single trig function and a single number. And then last one, this is probably like the hardest out of these. These are not terribly difficult though. I'll talk about why this one's going to be a little bit harder. All right, so which one has tangent plus tangent in the top? Yeah, fifth one, yeah, right here. Tangent plus tangent in the top, so that's tangent of u plus v. Tangent of u plus v. Label u and v. Plug those in. All right, these do not have a common denominator. So you cannot just add the top, add the bottom, or keep the bottom the same. Now, if you have this calculator, you can plug this in with the pi's. So let me show you what that would look like. Clear that up. 5 pi over 14 plus pi over 12. It'll give you your answer in terms of pi. 37 pi over 84. Your graphing calculator is going to give you a decimal for this, but I've got a little workaround that I can show you. So this is our actual answer, tangent of 37 pi over 84. So my initial, first instinct was, okay, I'm going to have to show them how to get a common denominator and add these by hand. But I think what you should do instead is, this is going to be on the graphing calculator, just take out the pi's and then make sure you stick the pi back in the numerator in the end. So do, on your graphing calculator, 5 over 14 plus, pretend like there's a 1 here, 1 pi over 12, so it'd be 1 over 12. If you add those, that's going to give you 37 over 84. And then you just remember to stick the pi back in the numerator. I think that's probably the best approach for adding or subtracting the fractions that don't have a common denominator on your graphing calculator. So just don't forget to stick that pi back in the numerator. And again, stop here. That's your final answer. All right, let me close this. All right, and stop my recording.